Hello everyone. So today I will be talking about different types of Wi-Fi 802.11. There's different types of them. They're not all the same. So when you buy a router or a Wi-Fi adapter, you just see you just see 802.11. But there's many different types of them. There's just 802.11, and that was originally introduced in 1997, up to 802.11ax, which is the latest one. So, so there's different versions, and they have different frequencies, and they have different bandwidths. They have different range, indoor ranges and outdoor ranges, and compatibilities. So they're not all the same. So today I'll be talking about that. So the first Wi-Fi adapter was released in 1997. It has a frequency of 2.4 gigahertz, and a lot of cordless phones back in the day had 2.4 gigahertz frequencies as well. And the bandwidth is about 1 megabit per second, or that's about 0.125 megabytes per second. That's less than a megabyte. It's pretty slow. It's pretty sorry. It's only like 125k bytes per second, which is not very good. Not for today, but back in 1997 it was pretty good because you didn't have broadband internet back then. But I guess it's not. It's still a lot slower than Ethernet networks back then, because I think they had up to 10 megabits per second back then for Ethernet. And anyways, the range for indoor is 20 feet, which is about 6.06 meters. The outdoor range is about 100 meters or 330 feet. Compatibility, I'm pretty sure it's compatible with A, B, and everything above. But nobody uses this anymore because it's too slow. And the next one is 802.11a. That was released in 1999. Has a frequency of 5 gigahertz, which is pretty high frequency, which is almost double the frequency of 2.4. So it definitely can penetrate through walls a lot better the higher the frequency. But then there's a bad side to having higher frequency. It means you would have less range. It's just slightly less. So the bandwidth is 11 megabits per second, or 1.38 megabytes per second. Has an indoor range of 25 to 75 feet, or that's about 7.58 to 22.8 meters for indoor range, and it's quite penetrating. It would go through the walls pretty easily. And it has an outdoor range of about 120 meters or 396 feet. And it's definitely not compatible. A is not compatible with B, and B is not compatible with A. So if you have a Wi-Fi adapter which is designated A, then it's not going to work with a router that's designated B. So the next one I'll be talking about is 802.11b. That was released in 1999 also. And it has a lower frequency of 2.4 gigahertz, but it has a much higher transfer bandwidth of 54 megabits per second, or 6.75 megabits per second, which is pretty good at that time even. So it has a range of 150 feet or 45.45 meters. 45.45 meters. So about 50 meters roughly. Outdoor range is 120 meters, 396 feet. The same as A. And again, this is not compatible with A. And you have 802.11g. that was released in 2003. It's about 2.4 gigahertz in frequency, and it has the same bandwidth as G has the same bandwidth as B, which is 54 megabits per second or 6.75 megabytes per second. Has an indoor range of 38 feet or 11.51 meters. Has an outdoor range of 140 meters or 496 feet. And the next one is 802.11n. That was released in 2009. It has dual channel frequencies of 2.4 gigahertz and 5 gigahertz. So at 2.4 gigahertz, so they have bandwidth of anywhere from 450 megabits per second to 600 megabits per second. So that's about 56.25 megabytes per second to 75 megabytes per second, which is pretty good at that time. It has a range of, they have different ranges depending on the band frequency, basically. So for 2.4 gigahertz, has a range of 53.3 meters or 176 feet. At 5 gigahertz, at the higher frequency, it has a slightly lower range of 48.7 meters or 161 feet. So outdoor range is about 250 meters for 2.4 gigahertz. That's 825 feet. And for 5 gigahertz, it has a range of 245 meters or 810 feet. So the N model is compatible with A, B, C, A, B, G. And it's probably compatible with this too. So everything here is compatible with the N model. So they're backwards compatible. So if you had an adapter which was a 802.11a, then it would work with a router which is capable of 802.11n. So all these would work basically. And the next one is 802.11ac. This was released in 2012, and it also has dual bandwidth of 2.4 gigahertz and 5 gigahertz. So it has a bandwidth of 450 megabits per second at 2.4 gigahertz and 1.3 gigabits per second or 1,300 megabits per second at 5 gigahertz. So 450 is 56.25 megabytes per second. And let's figure out what 1,300 megabits per second is. That's about 162.5 megabytes per second at 5 gigahertz. So the higher frequency, it has less range. However, it does have more bandwidth, and it could go through walls better. It could go through obstructions better, so that it's better in that respect. So at 2.4 gigahertz, the range is 150 feet or 45.5 meters. And at 5 gigahertz, it's 150 feet or 40.9 meters. So it's less range with higher frequency, but it does have better penetrating power, so you have to keep that in mind. So at outdoor range, the 2.4 gigahertz is 90.5 meters. That's 300 feet. At 5 gigahertz, that's 285 feet at 86.4 meters. And this is compatible with everything here. So compatible with this, A, B, G, N. So that's compatible with everything below that. They're all backwards compatible, which is good. So if you have a router which is 802.11ac, then you should be able to use, if you have an older laptop which has a 802.11b Wi-Fi adapter in it, then you should be able to hook up to this without any problem with to the AC model. So next one is 802.11ad. This was released in 2012 also. This isn't very common, but it does have a very high frequency of 60 gigahertz. This is how many times that? So it's roughly 25 times this 2.4, and it's roughly 12 times more than 5 gigahertz. So this is very high frequency. So the higher the frequency, well, it's using microwaves, so the higher the frequency, it definitely has a lot of penetration power. It could go through walls pretty easily, wooden stuff and everything else, plastic, whatever. It has a very short range, however, but it has a very high bandwidth of 6.7 gigabits per second, or 6,700 megabits per second. That's about 837.5 megabytes per second. That's pretty damn fast. So you could have a lot of devices. Well, you really can't, because it doesn't have a lot of range. So if you get close to it, you're going to get this bandwidth. So the range is 10.89 feet or 3.3 meters for indoor range. I don't know about outdoor range. I didn't find that. Compatibility, I'm not sure. I didn't get that information either. So as for 802.11AH, that was released in 2016. It has a frequency of 900 megahertz or 0.9 gigahertz. So this is far below everything here. So 0.9 gigahertz is less than 2.4 gigahertz, it's less than 5 gigahertz, and it's less than 60 gigahertz. So this has a low frequency, however, it does have a very long range, because that's how it works with radio waves and microwaves. So basically, the higher the frequency, you have if you have high frequency, you have low wavelengths. The wavelengths are less. So let me show you. So this is a high frequency wave, right? So you can see that the wavelength of this high frequency wave is shorter than the wavelength of this low frequency wave, which is longer. So radio waves can have very long, low frequency radio waves can have very long wavelengths, of perhaps as long as 10 meters or something, 33 feet. It could be very long, so it could have a very long range. But short range, high frequencies have short wavelengths. So the frequency of this is greater, and per cycle you got more wavelengths in one cycle, right? So one cycle of this would be equivalent to, let's say, 1,000 of these frequencies, basically, because this is high frequency and this is low frequency. So out of this one cycle, you could, if you compare this wavelength, you could fit 2 of these shorter wavelengths in here, basically. So that's how wavelengths work. So this has a longer range as a result of having longer wavelength and shorter frequency. So the next one is 802.11AX. That was released in 2019. And it's also a dual frequency of 2.4 gigahertz and 5 gigahertz. So at 2.4 gigahertz, you could transfer at 450 megabits per second. That's about 56.25 megabytes per second. And has and the 5 gigahertz model has 10 gigabits per second. And 10 gigabits is basically that's about 1.2 gigabytes per second. So that's 1.2 10 gigabits. Let me see, 10 gigabits. That's about 1.25 gigabytes per second, which is pretty good, which is pretty fast. I mean, a 10 gigabit LAN network will give you roughly about 125 megabytes per second. But with this thing, you're getting much more. You're getting 10 gigabits per second. So you're getting 1.25 gigabytes. So that's roughly how many times? That's roughly 10 times that of a gigabit LAN network, or RJ45 LAN network. So this is pretty damn fast. Don't know about the range. Haven't found any information on that. But this is going to be the new standard starting from 2020. And we'll get more information on that as it comes out. And as you can see, but people will wonder, wouldn't it be better to just have higher frequencies? Well, yes, because it definitely does provide higher bandwidth, but not really. This is actually much more than this. This is 6.7 gigabits per second. This is 10 gigabits per second. So as the technology gets better, they will be able to use less bandwidth to they will be able to use less frequencies to get better data bandwidth. So that's basically how it's going to be. So but in the future we'll see. So when you're looking for a Wi-Fi adapter or a Wi-Fi router, you should basically see what you're getting here, you know, because you don't want to get an old router with something that's like with a 802.11G, like, which was released in 2003, or if you have an old laptop, you may want to upgrade the old Wi-Fi adapter. So if you had this, the N, maybe you'd want to get something like the AH or something for your laptop, you know, a 802.11AH adapter, so you can increase the range and stuff if you need the range. So the problem with this lower frequency is it's not going to go through walls that as well as 2.4 or 5 gigahertz. That's one of the problems. But if you're outdoors, let's say you're controlling a drone or something with your laptop, then this would be good because you get very long range. So it depends on the application that you're using your electronic device for. So if you're using it to use a remote control a drone for a long distance, like beyond visual range, then this would probably be a good adapter to hook up to your laptop or something, if you have the software to do that, to connect to your drone via laptop computer. So these are the things that you should keep in mind when you buy an adapter or a Wi-Fi router. So anyways, that's it. So thanks for watching. My Ace 1000KS 1975